Hello, everybody. I would like to make a flow chart that helps us understand the conductor section or how to size conductors for electrical code. In Canada, this is section 4 of the Canadian Electrical Code, section 4 conductors, and I'm going to do a flow chart to figure out what we're supposed to do. And you probably know by now we're supposed to go to table 1 or table 2, table 3 or table 4 with correction factors specified in table 5A and 5C. But how does that all come together? When do we use what? So I like to think of it as a bit of a flow chart where we can just have that flow chart in front of us and go through a series of questions to always sort of get the right answer in doing conductor sizing in the electrical code. So I will call this section 4 conductor sizing, or whatever you want to call it. It's finding ampacity. And that is section 4 of the Canadian Electrical Code, and I'll sort of show you how to do it. I'll call this a math flowchart. All right, we find sizing of conductors in section 4, rule 004, and the majority of it is in subrule 1 and subrule 2. It's subrule 1 deals with copper and subrule 2 deals with aluminum. So what we're first going to do, let's make a nice fun flowchart about this. What we first do is we determine our material. So we ask ourselves, what is the material we're working with? And I could do a flowchart in lots and lots of different ways, but I'd like to do it this way. Am I working with copper or aluminum? Now, if I am working with copper, then I will use rule 4-004 ampacity. If I'm working with aluminum, I'll also use 4-004 ampacity. But for copper, I use subrule 1, and for aluminum, I use subrule 2. All right, so we already got somewhere in the code book in conductor sizing here, finding ampacity. I determined what material I'm going to use. And then I'm going to ask myself, how many conductors? That's your next question. Of course, you're only going to be working with copper or aluminum at this point, so you're only going to be on one branch of this flowchart at a time. All right, how many conductors are you working with? Now, you're probably going to be one conductor, or you're going to be more than one conductor. Specifically, we're actually going to make a little bit of a difference, and we're going to say one conductor in free air. Then we're going to say 1 to 3 in a run or raceway, or 2 or 3 conductor cables, and then we can do 4 or more in a run or a raceway. So that's actually similar for copper and aluminum. So let me draw that out. Your answer is going to be, well, sometimes you just have one conductor, and sometimes you have 1 to 3 conductors, and sometimes you have 4 or more. So I'm going to say 1 conductor. This is 1, 2, 3, and then this is 4 or more. And just to specify this a little bit further, this one conductor can be in a metal sheath. And it is in a free air run. The 1 to 3 conductors can be 1 to 3 in a run, or it can be 2 or 3 conductor cable. But if you have 4 or more in a run or raceway, you have to do something different. Specifically, you're going to be using table 2 and table 5C and possibly even 5A. So these are the 3 different things you would be doing. Now, I'm going to duplicate that over here. And then at this point, I'm just going to kind of leave aluminum alone because the table goes almost the same pattern. You're choosing these same choices, 1 to 3, with the same subsections or subnotes that I put over there. So duplicate these same subnotes over here, if you will, if you're following along with me here. And let me show you the results once you choose the size. So if you have this one conductor in free air, then you're going to simply use table 1. If you have 1 to 3 conductor in a run, or 2 and 3 conductor cables, you're going to be using table 2 with your copper. And if you have 4 or more in a run or a raceway, you're also going to use table 2. In a slightly different way, because you're going to have some factors associated with them. If you are aluminum, then you're going to be using table 3. If it's 1 to 3 conductors, it's going to be table 4. And 4 or more is going to be table 4 with 5A and 5C correction factors. Oh, down here, we're going to have 5A and 5C correction factors as well. This one's going to go into a 5A correction factor also if the ambient temperature is above 35. So, but we'll put all that in our flow chart. At this point, I'm going to kind of end the aluminum side of this flow chart, just because I'm not going to fit it all in here. But if you want me to develop the rest of this aluminum one on a different video, then just stick a comment to me and say that you need that. But at this point, I'm just going to end it. Because what you do over there in aluminum is very similar to what you do with copper here. Okay, so I've asked how many cables there are. Now let's develop this one, table 1. Now we're going to ask ourselves a question. Is the ambient temperature 30 degrees or less? Or is the ambient temperature over 30 degrees? So the temperature in which you're doing the installation. Or is the ambient temperature over 30? And we're talking about degrees Celsius here because we're in Canada. Okay, so if that one conductor is in ambient temperature of 30 degrees Celsius, we simply go to table 1. We simply take the value from table 1. If we want to install in an ambient temperature of greater than 30 degrees Celsius, we need to first go to table 5A for a correction factor. Now, if we got to go straight to table 1, then we can simply ask ourselves, what is the wire size? Table 1 actually has wire size, and it has the temperature. And this is going to be your insulation. If you don't know the temperature, the insulation rating, let's remember over here, note. You can get temperature, insulation rating for table 1, 2, 3, 4, etc. from insulation ratings are in table 19 of the Canadian Electrical Code. All right, so you know the wire size, you know the temperature insulation rating, and then all you're going to do is then go to the wire size down the side of the table, insulation rating at the top of the table, find where the two intersect, and that's where you're going to pull the ampacity out. So I'm just going to say pull ampacity off table. And you are finished. That is the simplest case. However, if you want to install in a hotter environment, then how hot would the environment be? So, how hot? Is it going to be 35 degrees Celsius, 40 degrees Celsius? Table 5A goes up, down this column by 5 degrees Celsius increments. So how hot is it going to be? How much higher than 30 degrees Celsius will it be? And then also, what is the temperature? What is the temperature insulation rating? So how hot can your actual cable be? And so in table 5A, you're going to have the temperature insulation rating, you're going to have the ambient temperature, and then from there, you will get a correction factor. All right, get the 5A correction factor. And then after I have that correction factor, that's when I am going to ask the same things I asked over here. What is the wire size? Wire size is going to be down here, down the rows. And what is the temperature insulation rating? That's going to be along the columns. And at that point, we pull ampacity off table 1. I should have said off table 1 here. All right, this is still from table 1, and that's what we're going to do. Let me erase this. So we could just go over here and say, we could say pull ampacity off table 1. Yeah, maybe I'll do that. I'll say pull ampacity off table 1. So that is our final answer there, is we pull ampacity off table 1, multiply by the correction factor. So we're going to pull the ampacity off, multiply the ampacity by the correction factor. Okay, that's if it's that's if it's one conductor. Here, I'll zoom out. So what we just did is we said there is one conductor in free air. I'm going to use table 1. If it's in ambient air temperature, I go straight to table 1 and I pull the ampacity off table 1. If we're going to operate in a hotter environment, I'm going to go to table 5A, get a correction factor, and then apply that correction factor to what I get off table 1. That's all the one conductor case. So let's look at the 1 to 3 conductor case in a run or 2 and 3 conductor cables, which is in the middle. So we'll use some different colors for those ones. In that case, we're looking at table 2. And if we simply have ambient temperature of 30 degrees, just like over here, it's like a regular installation in like room temperature. Then I simply go to table 2. I'm going to ask myself the size and the temperature, wire size and temperature, just like it did here. Wire size and the installation temperature. And I am going to pull ampacity off table 2. All right, I'm going to pull ampacity off table 2. However, if it's going to be ambient over 30 degrees Celsius, let me erase all these. If it's going to be ambient temperature over 30 degrees Celsius, just like here, ambient over 30 degrees Celsius, then I'm going to go straight to table 5A, just like I did here. And I'm going to say, well, how hot? I'm going to say, how hot? I'm going to do that in purple because it's similar to what I did here. How hot are we going to install this? And what is the insulation temperature rating? So same thing we did. Insulation temperature rating, which would be from table 19. And from there, I'm going to get the same thing, 5A. 5A correction factor. And I'm going to then get the ampacity from table 2, and I'm going to multiply that by the correction factor. All right, so I'm going to then multiply that by the correction factor, and I'm just looking for one thing, whether we need to also use 5C. And let me see, 1, 2, 3, except 5A, table 4 with the correction factor, 5C, 4 or more conductors. Okay, so we're not going to use 5C for this one. And so here I am, I will use this green. And I have the code book in front of me, by the way, and I was just double checking that we never use 5C for this 1 to 3 in a run. So I'm going to ask myself the wire size and the temperature, insulation rating. I'm going to go over to table 2, and I am going to, just like before, I am going to multiply ampacity by the correction factor. All right, there we go. So we have done so far, we've done the case of one conductor and the case of 1 to 3 conductors in a run or 2 and 3 conductor cable. Wonderful. Now there is another case. It is the case of 4 or more in a run or raceway. So let me try to get this on the flow chart for you. And I might have to erase here that I get temperature of insulation ratings from table 19. I'll put that somewhere else. Okay, so still working in copper. I have the case where I want to go to cable 2 because I have 4 or more in a run or raceway. Okay, 4 or more in a run or raceway, if it is all ambient temperatures, let me use red here, all ambient temperatures. This one's extra conservative because you have a lot of cables. So it doesn't even matter if you have a 30-degree condition. In all ambient temperatures, you are actually going to go to table 5A. And when you go and you're going to get table 5A factor. And when you go and you get that 5A factor, you are going to also get 5C factor. Table 5C. When you go to table 5C, you'll see that the table 5C asks you the number of conductors. And that's all it asks you. So you say, how many conductors? And it's going to give you a correction factor. And you're going to just you only have to know like the rows. There's no column thing to know. So you get the 5C correction factor. There you go. You get the 5C correction factor, and then you're getting the 5A factor by doing these things, and then you are going to multiply these two factors together. You're going to go and take these factors to table 2. Table 2. So you're going to bring 5C factor, and you're going to bring 5A factor, and then you're going to go to table 2, and from table 2, you're going to do that same thing again, where you are going to ask, what is the wire size? What is the insulation temperature rating? Table 19. And from there, you are going to get ampacity. Oh, I was saying pull ampacity. Pull ampacity off table 2. And at this point, you have to multiply by the correction factors. So I'll put my big lines up and say multiply by these correction factors. Multiply ampacity by correction factors 5A and 5C. All right, let me summarize that all for you then. Section 4, conductor sizing of the Canadian Electrical Code, which is finding ampacity. What we were doing in this section, it all sits on one page. It's called 4404. It's in subsection 1 for copper, subsection 2 for aluminum. So we wonder, are we working with copper? Then we'll go to subrule 1. Are we working with aluminum? We go to subrule 2. Then we say, how many conductors are we dealing with? Are we dealing with one conductor? Or are we dealing with more than one conductor? If we are dealing with one conductor, we're going to work in table 1. If we're in ambient temperature of more than 30 degrees, we go to table 5A for a correction factor and multiply that by what we pull off table 1. If we're in more than one conductor, we're going to go to table 2. If we work in hot ambient conditions, we get a correction factor from 5A before we pull the ampacity of table 2. If we have 4 or more in a run or raceway, gets a little bit more complicated because we do go and get that 5A factor, but we also go and get the 5C factor to deal with those extra conductors. We take the 5C factor, we take the 5A factor, and then we go over to table 2, we multiply them together by table 2. That makes sense to me. It makes more sense than reading it in the code book to me. In order to solve all these problems, I would sit this flowchart in front of me. I hope that you can duplicate this flowchart as a way of learning it and sit it in front of you for all of your questions as well. And you'll see that any of the conductor sizing problems that you have to do for section 4 of the Canadian Electrical Code become pretty straightforward, easy, and quick for you to solve. Let me know if you like this video by pressing like, subscribe if you want some example problems that use this video, and please comment below what did you like about it, what don't you like about it, and what do you need to learn more. Thanks so much for watching.